So now we are factor by grouping using the area model, and we have a problem. The very first thing we're supposed to do is make sure that this is actually written in standard form. If it is in standard form, that meant the highest exponent was written first. Looking at it, the highest exponent is not written first, so I need to rewrite it so the exponent is written first. So 105 n to the third power. If this is the highest exponent, the rest of the exponents are supposed to go down in descending order. So after 3 needs to come the exponent of a 2, and that is a positive 175n squared. So 3, 2, now I need the exponent of a 1, that's this one right here, and this is a negative 75n, so negative 75n. So 3, 2, 1, now I need the exponent of none, which is 0, and that's what this is. So it's a negative 125. So now that it is in standard form, we need to find the GCF. There are 4 terms. If there are 4 terms, then I need 4 lists. So here are my 4 lists, and now I need to come up with the prime factorization of all 4 of these. You may end up needing to use a factor tree to find it. 105 is 3 times 5 times 7, and then n to the third is n times n times n. 175 is 5 times 5 times 7, n squared is n times n. The only way to get a negative is if you have a negative 1. 1 is the only number that is allowed to be negative. 75 is 3 times 5 times 5, and then I have the n. The only way to get the negative is to have a negative 1. No other number is allowed to be negative. 125 is 5 times 5 times 5. So now looking to find my GCF, what do they have in common? They do not have any variables. I see that there is 1 5 in all of these. So that meant that my GCF is a 5. So that means when I come over here, you cannot forget your GCF. You need to say your GCF was a 5. And now you need to tell me what you still have since the 5 came out. So 4 lists means I need 4 things left over. So 3 times 7 is 21, and then your 3 n's. So this is 21n to the third. 5 times 7 is 35n squared. So here's my positive 35n squared. Negative 1 times 3 times 5 times n is a negative 15n. Negative 1 times 5 is a negative 25. So 4 terms because of the 4 lists. Now I need to do the area model. We're going to do the area model to this stuff right here. You start at the very front and you are going to walk your way through. So now that I have my area model filled out, I need to look at the first row and see if I can come up with this one GCF right here. So 21 and 35. 21 and 35 have a number 7 in common. He's the largest number that can go into these. N to the third and n squared, they each have a n squared. So now that I found the 1, the next step is to find all the rest of them using multiplication. So 7 times something needs to give me 21. So this is 7 times 3 will give me the 21. N squared times something needs to give me this n third, and it must be another n. So 7n squared times 3n is 21n to the third. 7 times something needs to give me the 35. 7 times 5 will give me the 35, and it already has the n squared, so no n's go here. 5 times something needs to give me this negative 25. Negative 5 times 5 is a negative 25. Now check the last one. Negative 5 times 3 is a negative 15, and then the n is already there. So we went ahead and we already found all the rest. So now step 5 is to write out your final answer. You cannot forget about the GCF. The GCF needs to be here. And then you are going to have 2 parentheses, and your 2 parentheses are represented by the sides. So this side is this parenthesis, and this side is this parenthesis. So this is a 7n squared minus 5. So 7n squared minus 5. This is a 3n and a positive 5. So 3n plus 5. And this is your final answer. So we're going to factor by grouping using the area model, and we have our problem. The very first thing is to make sure it's in standard form. If it's in standard form, the highest exponent goes first, and then it goes down in descending order. So 5, 4, 3, 2. We are already in standard form. So step 1 is done. Now we're going to find the GCF. There are 4 terms. So that means that I'm going to come up with 4 lists. Now to find the lists, you're going to have to use the prime factor tree. So on the scratch piece of paper over on the side, go ahead and use your prime factor tree. So 96 is 2 times 2 times 2 times 2 times 2 times 3. And end the fifth meant there were 5 of them. 1, 2, 3, 4, 5. Negative 84, the only number allowed to be negative is a negative 1. 84 is going to be 2 times 2 times 3 times 7. End of the fourth meant there were 4 of them. 112 is 2 times 2 times 2 times 2 times 7. End of the third meant there were 3 of them. Negative, the only number allowed to be negative is a negative 1. 98 is 2 times 7 times 7, and n squared meant n times n. So now I'm going to try and see if I can find a GCF. What do they have in common? I see that each one has a 2 in common. And unfortunately, I don't see any other numbers. 7s exist in these 3 lists, but a 7 does not exist in the first list, so you can't use a 7. I see that each list also has 2 n's in common. So my GCF is a 2 times an n times an n, because that's what I saw in every single list, which meant my GCF is a 2n squared. If this is my GCF, that means when I come over here, I need to write that I took out a 2n squared, and then I need to make sure that I write what was left over in all of the lists so I don't forget anything. So 2 times 2 times 2 times 2 times 3 is going to be a 48, and then don't forget the 3n still here, so this is 48n to the third. Negative 1 times 2 times 3 times 7 is a negative 42, and don't forget the 2n's here, so here's n squared. 2 times 2 times 2 times 5 is a 56, and then don't forget this n. And then I have a negative 1 times 7, which is a negative 49. So now that I've gone through all the GCF, it's time to put it into an area model. This is what you're going to end up putting into your area model. The first part goes right here, and then you're going to go ahead and just walk on through. Now that we have the area model filled out, we have to find this first one right here. So 48 and negative 42. The largest number that can go into each of those is a 6. If this is n to the third and n squared, the most amount of n's they have in common is 2, so it's n squared. So the GCF for this top row is 6n squared. Now I'm going to go around and just find the rest of them, and that's going to be using multiplication. So 6 times whatever number I write here needs to be 48. I know 6 times 8 gives me 48. Now n squared times whatever I write here needs to give me n to the third, which means I should have an n right here. 6 times this number needs to give me negative 42. So 6 times a negative 7 is a negative 42. The n squared is already there, so there are no n's. Negative 7 times whatever number I write here is a negative 49. So negative 7 times 7 is a negative 49. 7 times 8n is a 56n. So I went all the way around and made sure all the multiplication works. So the final step now is just to write your answer. So you cannot forget about your GCF. The GCF still stays here. And now we have 2 parentheses representing the 2 sides of the area model. So everything on this side goes in this parenthesis, and everything on this side goes in this parenthesis. So this is a 6n squared with a positive 7, so 6n squared with a positive 7, plus 7. This is an 8n with a negative 7. So this is 8n minus 7, because it was a negative 7. And this is our final answer, and we are done.